Alright, so here we are looking at part 2 of the ellipses and hyperbolas. The example we're going to look at here, or that we're going to focus on, is where my center is no longer at the origin and kind of how that affects things. So I want to compare all three of these conics on one graph to kind of really see the connection. So anything with this top conic I'm going to put in red ink. The middle conic I'm going to put in green ink, the bottom conic blue ink, and anything that they all have in common I'm going to put in black. So let's start with that. All of these are centered at the point 3, comma, -1. And again, I know that because I have x minus 3, x minus 3, x minus 3, which is why my x value is 3. And then when it's y plus 1, we're taking the opposite of that sign, so I'm subtracting a -1, which is why it's plus 1. So a -1 there, a -1 there, a -1 there. So they all have the same center. So I'm going to graph the center now just to kind of get that going. So at 3, -1, I'm going to put my dot. Well, now how are we going to create this box? Well, the box, a squared, which is again the value under my x term for all of these, is 9. So a squared equals 9, which means a equals 3. So in the x direction, I'm going to count to the right 3, put a dot, to the left 3, put a dot. In the y direction, I have b squared equals, well, what's the denominator of my y term? Each time I have 16. So b squared is 16, therefore b equals 4. So I'm going to go up 4, down 4. 1, 2, 3, 4, I can count. And I'm going to draw my box. So here's my lovely box. Fun, fun, fun. All the way to the y-axis here. Okay, so this is for all of them. All of them have that same start. So ellipse, hyperbola, start the same. Now, on the first one, which is in red, let's look at what type of conic this is. Well, there's a plus symbol here, and the denominators are different, which means this is going to be an ellipse, right? So this is an ellipse. We know that. So the ellipse that's in this box, again, this ellipse means it's inscribed in the box that we just formed. Well, the vertices are on the longer side here, which is the up 4, down 4. The co-vertices are on the shorter axis, or the minor axis, left 3, right 3. And then I'm just going to simply connect the dots, right? Pretty straightforward. Well, we're done with that. Let's look at the middle section here. So the middle one is in green. I'm looking for what type of conic this is first. And the type of conic is, for both of these actually, the green and the blue, since they're subtracting, is going to be a hyperbola. So I have the same box, which is why it's in black, it's shared, and I'm looking at how to graph this. Well, we're first going to need to graph the asymptotes, right? So I'm going to graph the asymptotes here. That starts there. Yes, yes, yes. Fun, fun, fun. There's that. From the center to the vertices of this box. Now, if I want to look for the equation of those asymptotes, what do I need? Hopefully you remember from the last video. Since they are a line, I need this information. Meaning I need a point, and I need the slope. Well, the slope, again, if we're counting from the center, the rise is 4, the run is 3. Well, my other asymptote, the rise is 4, and the run is -3. So my slopes are just going to be plus and minus, plus or minus 4/3. And the point that I'm going to use is going to be the point that they both hit, meaning the intersection of these two asymptotes. Well, where do they intersect? They intersect at the center, which we already know from previous information. So the point is the center, which is 3, -1. So if I want to, oops, hold on. If I want to write the equation here, then I'm going to have two different cases. So the first case, is going to be y plus 1 equals positive 4/3 x minus 3. And the second case is going to be y plus 1 equals negative 4/3 x minus 3. Now some people have just written a plus or minus 4/3 x minus 3. I would caution you not to do that every time. If your teacher wants you to put it into slope-intercept form or standard form, then you're going to have to distribute, get y by itself, etc., 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 just using Algebra 1 skills. Well, if that's the case, you're going to get different values over here and different y-intercepts, which means sometimes it's easier just if you want to put it into slope-intercept form, it's easier to write them separately. So if your teacher's fine with you just keeping it as point-slope form, then putting the plus or minus, so writing it like this, y plus 1 equals plus or minus 4/3 x minus 3, which I'm absolutely okay with most of the time. Alright, well, how do we graph the green and the blue? So the green, which term is my positive term, meaning which term's in front? Well, the x term is in front, which means it's going to be going left and right. So I'm going to go to the vertices there, draw it close to the asymptotes. Vertices here, draw it close to the asymptotes, and we're good. The blue here has the y term as a positive, which means it's just going to be, same box, etc., etc. It's just now it's going to be vertical. So they're all three of these things are very much connected to each other. They have the same box. They have the same center. The two hyperbolas, the blue and the green here, have the same asymptotes, and just one of them is going vertically, one of them is going horizontally. So you should be able to piece these together quite nicely. Okay, let's look at one. Oh, wait a minute, what is this? Oh, we already talked about this. Ignore it. Doesn't matter. Okay, we've already done this. Let's move on. So here's kind of a critical thinking question for you. Find three conics formed by the box with vertices at 3, 1, which is here, 1, 1, 3, negative 3, and 1, negative 3. So here's the box. And what it's asking is what conics are formed by this. Well, as we just saw in the last example, it's either going to be an ellipse, which would be formed here. Perfectly drawn, of course, right? Isn't that lovely? Well, what do we know about this ellipse? Well, the center, actually for any conic here, the center is going to be right in the middle there. Since it's going up, the major axis here is 4, then that means it went up 2, down 2, right? So if I wanted the center, I'm just going to count down 2 from the center, which means it has a y value of negative 1. And going left and right, if the x-coordinate is 1 and 3, right in between those, the midpoint of those would be 2. So my center is the point 2, negative 1, which means I'm going to have something like x minus 2 squared. I'm going to have something like y plus 1 squared built in here. Well, again, how much does it go up and how much does it go down? It goes up 2, down 2, which means b squared. b is 2, which means b squared is 4. So that's under my y term. Well, it goes left 1 and right 1, so a is 1. Alright, let me get rid of that, actually. A is 1, which means a squared is 1, and that's under my x term. Well, I can then quickly, since they're hyperbolas or ellipses, set those equal to 1. One of them is going to be the ellipse, which is the plus. Ta-da. One of them is going to be the horizontal hyperbola, which, here's my vertices, my asymptotes. the horizontal will be here, sloppily drawn, of course, in typical Cron's fashion. And that's where the x term is positive. So that's here, right? Again, this is just a quick sketch, so you can go on with your day. And the other possibility is the, oops, actually let's do this, is the hyperbola where the y term is positive. So y plus 1 squared over 4 minus x minus 2 squared over 1 equals 1. Now oftentimes you're not going to see this over 1 because the dividing by 1 is kind of redundant, which is fine. If you don't write it as a fraction, that's okay. And this one, the y term is positive, so this one's just going to be starting at the vertex there and going up and down. So we have 3 conics. Again, these are the 2 hyperbolas here, and then the only difference is this one can change into an ellipse. So we have those 2 and that one, those 2 and that one, those 2 and that one. One more time, those 2 hyperbolas and that one ellipse. So there we have it. That's kind of your intro to ellipses and hyperbolas. Fun just thought, I guess, is if you wanted to know what the equation of the asymptotes here of the hyperbolas, well, what would we do? We know that this slope, which we can call m, is going to be up 2 over 1, which is just 2, and the point is going to be your center, which is 2, negative 1. And then you have y plus 1. Let me move this down so we have more room. Y plus 1 equals plus or minus the slope and x minus 2. And again, if you're asking to put that into slope-intercept form or standard form, split those up into 2 cases, then distribute and go from there. Alright, hope that helps. That's all I got for you. If I do another video on ellipses and hyperbolas, it will be focusing on, I did not intend to put that pun in there. It will be focusing on the focus, or the foci. So, yeah, that's that. Have fun. Math is fun. Goodbye.